Okay, so everybody knows the Pythagorean theorem, right? A squared plus b squared equals c squared. But we are told that only works for when triangles have a 90-degree angle. So that got me thinking, what happens if the triangle has an 89-degree angle or 91-degree angle? So that's what I investigated here. So I used the law of cosines to figure out what the hypotenuse would be when we have an angle that's close to 90. And I started off with the 3, 4, 5 triangle. So when z is going to be our angle that's supposed to be 90 degrees but isn't, and h is our hypotenuse, right? When z is 89, right, the angle or the hypotenuse is going to be about 4.957. And that is, if you round to the nearest tenth, you're still going to have 5 as your hypotenuse. Same thing when z is 91. If you round to the nearest tenth, you're still going to have 5 as your hypotenuse. We start to lose our ability to round to the nearest tenth and still have our hypotenuse around when it's 2 degrees off. All right, you see that with the 88 and the 92. Then we're losing our ability, and it's getting farther and farther away from the actual hypotenuse itself, which is what you would expect to see. Still, though, if we decide to round to the nearest integer, which obviously is not as accurate as just having the actual thing, it's going to give you 5 every single time for the 5 degrees that's off, up or down. Now, I investigated the differences of going up or down 1 degree on what it would actually be, and I found when you were going down 1 degree, all right, so that means going from 89 to 88, all right, every single time the inaccuracy of our calculation increases by about 43 thousandths. Okay, then when it's going up in the 3, 4, 5 triangle, all right, this is just the 3, 4, 5 triangle we're talking about, the inaccuracy increases by approximately 41 thousandths. Now, there is some vary in there. Sometimes it's about 43 thousandths, sometimes 41 thousandths, sometimes 44 thousandths, but it's about that. Now, if we look at going down, how much it varies in our inaccuracy. So what I mean by that is going from 88 and going from 89 to 88, the inaccuracy is all increases by 43 thousandths. Same thing from 88 to 87, and then from 86 to 85 increases by 44 thousandths. So we only have one change. Then if we look at going up, though, if we go from 91 to 92, it increases by 44 thousandths. Then 92 to 93, 41 thousandths. Same thing again for 43 to 44. Then if you go to 44 to 45, it increases again by 40. It increases by 40 thousandths. So there's more vary. But if we look at the numbers, if you had to choose between, if you had to give a close estimate, and you had to choose between going up a degree or down a degree, you would want to choose going up a degree because it's going to be a little bit closer. Still, they're about the same, but if you go up a degree, it's a bit closer than if you went down a degree. So I looked, okay, that's for the 3, 4, 5 triangle, but if we look at the 5, 12, 13 triangle, will that be the same thing? And the answer was yes, essentially. So once again, if we look at the differences, going up or going down has less vary, just like the 3, 4, 5 triangle, but then going up has more vary, but going up is more likely to give you, actually not more likely, it is going to give you a better estimate of what it actually is. So these are my findings. If you found anything to be false or have any additional things to add, just put them in the comments. Thank you.